And let's get it on. So welcome to not potentially, this series of videos where I'm trying to redo, replicate, review, remember a project, a work that I did some time ago, 5 years ago, back when I was doing my master's, and I decided I wanted to revisit and do the whole coding thing because apparently I'm losing my memory. So the first videos, I think was 3 first videos, I explained a little bit more of the introductory part. So this is about area prioritization for biodiversity conservation, specifically in a very particular region in the center of Mexico, because I studied there. This is with the idea that we can find the environmental ideal places for a set of biodiversity, right? And that withstand climatic and land use change. So today, I'm trying to move on a little bit more into the actual thing. This is one of the slides that I used to explain some of the processes. So for today, I will going to be attempting to do the variable selection, the environmental information selection. So how does that actually work? In theory, because I am working with rasterized information, basically is like an image, like a photograph with pixels, right? And each one of those pixels contains certain type of information. For example, a value for mean temperature, a value for mean precipitation, the value for the warmest month, etc., etc., etc. I explained that in in a past video. So I use that information, and in addition, I use occurrences for the species of interest. Back in that time, I used 94 species. Over here, because I'm just trying to focus more in the methodology, I am going to be using only amphibians. Back in the day, I also used reptiles, mammals, and birds. So in here, it's going to be very easy, hopefully, only like 10 species. So it should be easy, few records. So hopefully it goes smoothly, right? So we use an algorithm, in this case is a linear model in a package called GLMulti for the language R, right? If you're not familiar with it, it's just a programming statistical kind of thing. It's like your SPSS or Excel on steroids. So using those tools and that information, we create a set of the most informative climatic information for each one of the species. Usually when we work with modeling, species modelation and that kind of thing, usually like the 19 variables are thrown into the whole thing, and maybe apparently it's not as efficient as it could be. So here something that was really cool at the time was the fact that we were trying to be specific for each one of the species. So that's basically what is going on here. Now, just also as a recap, I just want to explain again, show very quickly. When I show this 10 by 10 kilometers, so what do I mean? So we took the whole country of Mexico and created like a full grid, like a pixelized right thing. And each one of those pixels has a centroid. So this is how it technically looks like. Is it this one? Yes. So if you see, if I zoom in, we can see each one of okay, zoom in. There we go. So, is it coming? They are coming. Oh, I need to move. I set them up like very, very tiny, but I think you can see them. Let me see if I can just make them a little bit bigger. Apologies, I work with a very old computer, so there's that. Give me some size. No, I'm not going to be that big. Let's do it. So one of each points is the centroid of the pixels, right? So each one of those things has some kind of environmental information. But because we try to do it also like in a more detailed way, for the modeling, which is going to come up later on, we did it at 1 by 1 kilometer. So this is how it looks. So as you see, the area of interest is way smaller than the area for variable selection and the prediction. So why did we do it? Why did we do it like that? Well, basically because species do not restrict themselves to political delimitations, right? So we wanted to cover to gather as much climatic information as possible. This is a standard practice on this kind of projects, right? So as you see, some of the occurrences of this species, so obviously each one of the colors is a different species that you can see it here. I'm not going to go into that thing, but this is basically how it works, right? So we know that we're going to be collecting data from each. I'm not going to go into the whole thing, but this is basically the idea. Selection and calibration of the models, selection of climatic information and calibration of the models at a very wider range in projection to a very specific place. Eventually, as we advance, we will be moving on. And the final file that I am trying to produce for this time is something like this. I also went through it in a past video where each one of these represents the 19 variables and the 7 land use classes. And each one of these lines represent each one of the species. And as a binary thing, so this, and that is going to be the set. So this is basically what we are attempting to do. And here's the snippet of the code. So I'm trying to do this as raw as possible. So I might be having some hiccups and hopefully not many. And maybe I will need to pause the record from time to time because I think some of these processes can take a little bit of time. So, and also, yeah, so I mean, as you see, like this is, right now is just this, what we are going to be working with. Afterwards is a calibration model. This is a very long script. So here I need to read the variables, right? This is the variable information, the climatic information. So for this, if, for example, if I want to show so as you see, I have each one of these. Now, a very important thing is that I'm hoping I have that located in the code. Alt is altitude. Initially, we thought we could include it, but we cannot include altitude when we are working with time series. So there's that, right? Just keep in mind. Then we need to read the table. Well, I actually already have it over here. If you can see on the right side, I've already read that because I was getting some errors. So for that, you can see this. So we have the first 10 records. So this is one of the species. This is the location coordinates, but actually all the calculations is with the ID grid. This is another thing that was done previously to this, because we work with the IDs of the grids, not specifically with the location of the species, but as long as the species is located within the grid, this is the value that we'll be working with. Another information, well, yeah, it's this thing that tells me like the location of each one of the centroids. So the whole idea, well, in the beginning I loaded the 2 packages that I need for this process, the GLMulti and Java, which one of those was the one who was making the mess. So Finally, before starting the loop, I create a grid, basically with all zeros, and that grid is the one that is going to allow me to set everything up afterwards, right? So the way that this is calculated is the length of the many names that I have against 27, which is the number of potential variables that I have. So that's basically what it's doing here. Yeah, it's just creating a matrix. Yeah, so the first, we need to configure the loop that is going to be cycling in each one of the names. So this is going to be 10 cycles. Next, we are going to bring the name. Okay, so I'm going to just test it, crossing my fingers, for only one, right? So the first cycle, right? So first I need to indicate which of the species is the one that I'm going to be working. So this is it. This is the name. Then get each one of the lines where the species is recorded. Now, we need to keep in mind this is talking about the full country, right? So in all these thousands of points, where do I have my species matching the centroid? And for that, boom, 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 boom. So I have it on those lines. Hopefully, yeah. Then I need to know no, yeah, sorry. So this means like from, I need to correct that comment. From the table of occurrences of my species, in which lines do I find the first species? So obviously it's going to be from 1 to 7. That means that I have 27 records of the presence of that species. As a reference for all the species, ideally we want to have more than 14. Yeah, so because this is amphibians, it's hard to have a lot of the records. Now, I think this is the one that is going to tell me the grid ID. These guys are the grid IDs, right? Now, this is creating only absences. Yeah, this is the number. So for the full country, we have 25,000, well, almost 26,000 points. And then is to match each one with the other one. So I don't think we're going to be able to see it. So the whole thing is yes. So now here's where we are going to match the ID from the variables to the IDs of the occurrences. And to that, we are going to assign as 1. This guy, which is the present, so I am not going to, I really don't remember the full theory again, and I want to keep this video within relatively like good amount of time, and I'm almost done. So here is the whole algorithm where I need to specify the algorithm that I'm going to be using, the minimum size of selected variables. Wait, oh my gosh, I think I will need to make a pause and then later on explain the setup. I do apologize. I will go ahead and do that. But anyway, so here's where we have the calculation and get the names of the variables. Yes, the comments are in Spanish because I was taught in Mexico. So names, so get the variable name and then match the names from each one of those Can I run it? Let me go ahead and try to run this guy. So far, I have all of that. Okay, so I'm gonna make a very quick pause just in case this is going to take too much time. So also record. Okay, so it's going. So to explain very quick the setup over here, I brought up the documentation immediately. So just to be clear, the most important things to pay attention is this part. The coefficient is whatever. The function is the general linear model. The method G. I will go ahead and just mention them very quickly. But the most important thing that needed to be set up, it was that one, because level refers to select the one, like the way that it's going to select the variable, which is the one who has the most effect or the most information gathered. That's the whole idea. Then the minimum size of the set should be 4, and the max is was 10. In this case, it's still 10. We limit the number to 10 because we didn't want to have like a very huge set, and this is mostly because oh my god, and here it is. Paying attention and consistency. I don't care, it's going like that, raw. So the whole thing about having a maximum size was because we didn't want to have like a very big variable set, because it's going to be already a very heavy process. Again, this is I did everything with this 7-year-old laptop. It handled it pretty well, but it was hard to do it. So we try to control everything. So this mostly the only reasons why we set up the algorithm like that. And as you see, even though I have already made a quick pause, the algorithm is still going. Hopefully, I really don't remember how much time it took, and I am running only one species. So maybe I will leave it over here. I will leave the whole process here, and I will continue showing the results in the next video. Oh, well, it actually finished. Yeah. So technically, we already have all of this. This should give me the final result. Amp bar should be a line of zeros and ones. Boom. So what you see here is the matrix. Obviously, it's only the first line because it's the first species. Yeah, so this is so cool because it went like smoothly, I mean, within the time, almost less. I mean, it's fine. And so this is the type of thing that we are looking to get, right? Now, just for the sake of curiosity, I'm hoping I should have the same results. I'm gonna bring the old table, and it's not the case. This is interesting. Yeah, maybe there was a different calculation. So I have 2, 3, 2 zeros. Yeah, so it was a very different calculation. This is interesting. Consistency, a different way that it was processed. We will see how it looks in the end. Yeah, because this is interesting to have it like that. I see that 20 was also selected. So there might be a difference. Actually, oh yeah, just one last thing that I wanted to point it out. I mentioned that we did not use altitude, right? Here's where we eliminate the altitude. This is very important, just for the sake of keeping the information. Yeah. So here's where we eliminate altitude because it was the very first column. But okay, so I'm going to be leaving the video over here. 20 minutes is already too much. And I will be showing the results for the full table and moving on to the next process. So thank you once again, and see you until I see you. Bye-bye.